Hey Mona, okay, you want to know about wholes, and obviously this has to do with rational functions. So I'm referring here to page 145. So you can just look this up yourself or whatever. I'll talk you through it if you want. Um, so they start out values for which a rational function is undefined. The denominator is 0. Result in a vertical asymptote or a hole. Well, what's the difference? Well, they show it right here. Okay, so here you've got f of x equals x squared minus x minus 2 divided by x squared minus x minus 6. Now, if you factor the denominator, you got two values of x for which the denominator would equal 0, negative 2 and positive 3. So if the denominator were simply 1 or x or something that did not cancel with any of the factors in the denominator, then you would have two vertical asymptotes. You would have a vertical asymptote at negative 2, and you would have a vertical asymptote at 3. And, okay, so why don't you have two vertical asymptotes? Well, the reason for that is that you have a factor in the numerator which cancels with one of the factors in the denominator. And that, namely, that's x plus 2, because the numerator factors into x minus 1 times x plus 2. So you have x minus 1 times x plus 2 over x plus 2 times x minus 3. Now, the x plus 2's factors cancel, and so you're left with a simplified rational function of x minus 1 over x minus 3. Now, note the qualification that's next to that, namely x may not equal negative 2. So what that means is that instead of there being a vertical asymptote at negative 2, instead there is a hole in the graph. And in order to find that hole, you plug in negative 2 into the simplified form. Okay, so we plug in negative 2 into this, so we get negative 2 minus 1, that's negative 3, over negative 2 minus 5. So we have negative 3/5, I believe, or 3/5, negative 3 over negative 5. So you're going to have 3/5. That's going to be the y coordinate when x equals 0. Well, I'm sorry, when x equals negative 2. And so that's, you're going to have a hole there. So at negative 2 comma 3/5, there will be a hole in the graph. So here's negative 2 right here, and here's y equals 3/5. Okay? And the graph is undefined here. Now they show you, if you put this in the calculator, let's go ahead and do that. So we'll put in the numerator, x squared plus x minus 2 divided by x squared minus x minus 6. Okay, and we'll just graph this on the regular screen. Zoom standard. Okay. Now, instead of seeing a graph with two vertical asymptotes, we only have one. Now, this graph, no matter what we do to this graph, it's not going to show us the whole. We can play with the window so it only shows us this little region of the graph. It's not going to make any difference. So, but as they say here, you can go to the table, however, and so we'll do that. Excuse me. And if you go to x equals negative 2, you'll see it's not defined. So, but it is defined for negative 5, negative, and then negative 3. And there's no asymptotic behavior like there is at 3. Now let's look at 3. Now we don't actually see the asymptotes happening. In order to see that, let's let's make the delta table 0.1. Okay, so we're going to proceed by tenths, and then we'll go to our table here. Okay, so we don't see any asymptotic behavior here at, as it gets closer and closer. We don't have y getting really huge or whatever. It's just proceeding as if it were on a continuous line, then boom, it hits -2, and it's like there's a manhole cover in the street or something, and then it just doesn't go any further. Now let's go down to, let's take us a second here to get down to, okay, now let's go to 3, and here you've got asymptotic behavior, okay, where you can see it's getting really big exponentially. Okay, now let's go here and let's change this to 0.01. Okay. Okay, so now we're going by tenths. Okay, and now you can see here's the asymptotic behavior. We're going up by tenths. Okay, and it's really approaching, it's getting really big in the negative direction. Okay, you can see how quickly it's approaching. And then we could go into hundredths and then thousandths. So that's the asymptote. And then we go one more, and we go on the other side, and look, it's 2. So you see the asymptote on the other side, the asymptotic behavior on the other side. Okay, so when can you remove a hole? You remove a hole when you have a factor in the numerator and the denominator that cancel out. Then you have an asymptote turn into a hole. So when you're drawing, then if you're drawing the graph, you'd put a hole in at -2, 3, 5. And so they have exercise 23. So let's take a look at exercise 23. Okay. So you can see, let's get a scratch pad for this. Okay, so 23. F of x equals x squared minus 25 over x squared plus 5x. So we cancel numerator and denominator. X minus 5 times x plus 5 over x times x plus 5. Okay, now we take x times x plus 5 equals 0. So we have x equals 0. So there's a potential vertical asymptote at x equals 0. And then we take x plus 5 equals 0. And so at x equals -5, there's a possible vertical asymptote. However, these guys are going to cancel. So instead of having something with 2 vertical asymptotes, which would look, I don't know, depending how, it could look like this or whatever, something like that or whatever. Instead of having that, what we're going to have is x minus 5 over x, comma, x is not equal to -5. Now, we put in, now how do we know the y value? So we have a hole at -5. So we put in -5 minus 5. We're going to plug in x into the simplified form. And we're going to get -10 over -5. which is 2. So at negative 5, comma 2, there is a hole. Okay, so we're graphing, what are we left with? X minus 5 over x. Okay, so vertical asymptote, x equals 0. There's a hole at negative 5, comma 2. There is a horizontal asymptote at x equals 1 because the degrees are the same. And there's, when x equals 0, well, x equals 0 is a vertical asymptote, so there's no y-intercept. No y-intercept, which makes sense because the y-axis is the asymptote, but there's an x-intercept when x equals 5. So we have 0 over 5, y equals 0. So at 5, comma 0, we have a y-intercept. Okay, so with this information, we're sort of ready to make a graph. Only it doesn't want to. I want this thing. Okay, let's go up a little bit. All right. So let's put some of this information on here. Okay, so at 5, comma 0, 1, 2, 3, 4, 5. Okay. And the vertical asymptote is x equals 0, and then y equals 1 is the horizontal asymptote. Now, we're not going to cross this asymptote, so I know right away I'm not going to cross this asymptote, and I'm not going to cross this one. So I know right away the graph has to look like this, right away. And then I said there was a hole at negative 5, comma 2. 1, 2, 3, 4, 5, and then at 2, 1, 2. So I'm going to put my hole in here. Okay. Now I hope this clears things up for you. You have a hole versus an asymptote when you have a factor in the denominator and a factor in the numerator that cancel each other out. That creates a hole. Now, when you have a factor in the denominator that makes the denominator equal to 0, and it doesn't cancel, then whatever value of x that makes that factor equal to 0 is an asymptote. But when you have a factor in the denominator that makes the denominator equal to 0, and it doesn't cancel, you have an asymptote. When it does cancel, then you have a hole. That's about it.